Okay, question 53 on section 2.5. So we've got solutions, which means they are zeros. X equals 0. Oh, wait. Oh, yeah, there's actually, that's only giving us 4 of the zeros. That's right, because it's saying that we're taking the function and setting it equal to 0. And therefore, we're getting the solutions, positive negative 2 and positive negative 7i. But then, on the second part, it gives us a leading term with a degree of 5. That means we're missing a 0. Okay. So, solutions are x equals plus or minus 2 and plus or minus 7i. So that would be x minus 2, x plus 2, x plus 7i, x minus 7i, and this last part would turn into x squared plus 49, I think, wouldn't it? Because when you FOIL it out, the negative 7xi, positive 7xi cancel, and we get negative 49i squared. I squared turns into negative 1, so we get positive. Right? Okay. Now the thing is, we want it to be degree 5 with negative 3 at the beginning. So I'm going to go ahead and throw in a negative 3 in here so that I have that part of it. But in order to make it degree 5, I'm also going to multiply this together because this will make it easier in the long run. So this one will turn into a difference of squares, x squared minus 4, won't it? So then we'd have negative 3 times this stuff. But then we need one more 0 to get to degree 5. We don't know what that 0 is. So let's throw in another thing and call it just C for some other 0 that we don't know yet. Okay? Now what we do know about this is if we plug in, so this is the third item, if we plug in a 2, we're going to get 0. The 0.20 is a local maximum of the graph. Wait. Oh, okay. Figuring this out as I go. Sorry, done this pop-up. We actually don't need to. Because I just figured it out. Draw a picture if you need to visualize what it's saying. I'm going to go ahead and draw a picture and put what I know on here. So I have a positive 2 and a negative 2. So the very last statement is the 0.20, so that's that point right there, is a maximum. That means that the graph is going to go up to that point and bounce off of it like that. What does that tell us about multiplicity? Has to cross through to be 1, like a linear. And if it bounces like a parabola, it's multiplicity 2. Okay, so if it's multiplicity 2 right there, then that actually, go back. You can leave yours on your paper, it's fine. I mean, it's not like what I wrote is totally wrong. All right, so we have an x minus 2 and an x plus 2. I'm just sort of rewriting it. And we have an x minus 7i. I probably didn't need to erase it. I just wanted to start writing. So don't start erasing. Just kind of hear me out. Oh, sorry, I'm so scattered. Okay. So we just figured out that this point at 2 has to have a multiplicity of 2 in order for it to touch the graph and go back down, because that's a maximum, a local maximum, right? So what do we need in order to have a multiplicity of 2 on that point? We need to square which one?
Minus.
Yes, because this is at a positive 2, so the factor that's squared would be the x minus 2. Okay, now you can maybe see where I'm going and why I sort of erased even though some of that was right. Okay, So then we still have the matter of the leading coefficient, which is -3. So now, are the requirements that the coefficients are all, can we say that that answer is done, or do you think we need to do the multiplied out x squared plus 43? It doesn't really say. It says leave the polynomial in factor form, but it doesn't say anything about non-reducible quadratic factors. I think we could maybe say this is done. If you wanted it to have an irreducible quadratic factor instead, so that everything's real, then you could just do it this way. So I feel like either of those answers would be accurate. And we have our degree 5, 1, 2, 3, 4, and our leading coefficient. Does that fulfill all the requirements? I know I was all over the place changing my mind, so just double check me here. I've made mistakes in the past and I need your help to make sure I don't make them. So don't be afraid to tell me.
So is it, why is it the multiplicity?
Okay, so that goes back to section 2.2. We talked about multiplicity in section 2.2. Let me see if I can find those notes really fast. I think that might help. Okay. Okay, so I found this from our section 2.2 notes. The multiplicity of a zero, if f is a polynomial function, x equals c is a zero of multiplicity m. If m is even, the graph touches and rebounds from the x-axis. If m is odd, the graph crosses through the x-axis at that point. So I just made this problem up really fast, and then we figured out the zeros. We figured out their multiplicity, and based on that, the multiplicity tells us whether it's going to touch or cross the graph at each point. This one is going to touch the graph, and it's going to look like a parabola at that point. This one's going to cross the graph and look kind of like an x cubed at that point because it's multiplicity 3. This one's going to cross the graph and look just linear at that point because it's multiplicity 1. So altogether, let's talk about the degree of this problem. This would be degree 2, 3, 6. Degree 6, right? So x squared, x cubed, x. So multiply those together, we have degree 6, which means since its leading coefficient is positive, and behave yourself up. So just a rough graph. We have a point at 0, we have a point at 3, we have a point at -4. The ends are up. So remember, at -4, it's just going to go straight through. At 0, it's going to bounce. At +3, it's going to be more of a little curvy thing like that because of the multiplicity of those zeros. So it just gives us an idea of what they look like. Now, I don't care so much about linear versus x cubed. That part doesn't matter so much. What matters is knowing whether it's going to touch or cross the x-axis.